All right, welcome everyone to Civo Navigate, Texas, USA. Good to be here. I flew from London. Very excited. Still a little bit jet lagged, but I work at Civo, so I'm one of the. Don't know if you can see my staff T-shirt. My name is Kunal. I work as a DevRel manager here, and it's very happy that you all came to the event. We're going to talk about platform engineering, and very excited for this talk. This is a Slido poll thing. It's anonymous, so if you can just scan and let me just play this. There's only one question because I see it floating around quite a lot. People say, DevOps is dead. Has anyone heard of that? Raise of hands. So what are your thoughts when someone says that? Just write it down. And it's anonymous, so I'm just interested. All right, some people are typing. It's nice weather today. We don't get a lot of sun in the UK, so it's good. Undying, revive it. A few more responses and we'll move on. How many folks know what platform engineering is? A raise of hands. How many folks are new? I know you from Twitter. Nice, thanks for coming. So many Twitter people I'm seeing. Okay, a lot of beginners, I would say then. Okay, good. Very nice. Immortal is going to die. DevOps engineers, be tired. Clickbait. It is a clickbait. That's a good one. Whoever wrote that. But all right, I'm going to close this. If you want to I'm going to take a screenshot. It's good for Twitter or X. All right. So we're going to talk about navigating platform engineering. Before we get started, with the whole agenda, because we have a lot of beginners, what is platform engineering? Let's take an example of imagine you're building a very nice Lego castle. I don't know if anyone is giving away Legos. Maybe you can check out some of the sponsor booths. But when you're building Legos, you have like you need a box that has Lego bricks. And if you have ever built a Lego, you will see that it's very well organized. There are various components in various plastic papers, and you have the whole information and everything. So platform engineering is like preparing this, that box of Lego bricks for you, and it makes sure that you have all the different types of bricks that you may need to build your city, like platform, like the windows and the doors and the walls and all these other things, and that it's also organized and very easy to use. And this way you can focus on what? You can focus on building your Lego set, building your castle without worrying about making the bricks yourself. So in the world of computer programming, the platform engineering is like preparing this box of tools for programmers, right? So if it gives everything to the developers that they need, like your clusters, your storage, in simple terms, your servers, all the other components and special software and all these other things. And because they have this quote-unquote box, which is ready and organized, programmers can create very cool applications and websites more quickly, just like you can build your Lego castle better if you have all the right tools and stuff provided to you. Why do we care? What are the advantages? Because developers don't really like, working with YAML. I've heard that at KubeCon. And you can help developers create apps faster because you don't have to build everything. A lot of TVs, nice, because you don't have to build a lot of things from scratch. So I think saves time. The platform also provides tools and services that helps make better and more reliable applications. It's also cheaper because you reuse a lot of tools and infrastructure instead of making new ones every time. And developers can also try new things very easily, which leads to more creative and advanced applications. And as more people use the applications, the platform can also adjust based on extra demand smoothly. It also makes sure that the apps work really well, all the time, reducing the crashes and problems. And the platform also includes, let's say, strong security measures to protect against hackers or whatever. And lastly, also continuously improving the application becomes much simpler and faster. Simply, that's what, in simple terms, platform engineering is, but we'll talk a little bit more about it in this session. Agenda of this session is we're going to talk about the evolution of platform engineering. Everyone has a different definition. Everyone has a different perspective. So I'm happy to also hear your views around what you think platform engineering is, where it's headed, and the role in modern organizations. That's something we'll talk about. We'll talk about internal development portals. We'll talk about SaaS solutions. We'll talk about a decision-making framework, like, okay, you want to implement platform engineering. What do you do? How do you get started? What are the action items? So let's dive into the first point, which is the evolution of platform engineering. So long ago, when in the early days, it were all manual and basics. Shout out to DALL-E. I got it from ChatGPT DALL-E. You put in prompts, you get like, I just put in like old servers, manual and everything. But yeah, very, very nice tool. So in the beginning, when everything was, things were happening manually, if you wanted to build an app, then you had to set up your own servers, you configure, your networks, you have do all the technical stuff yourself. It's like baking a cake from scratch every single time. Okay, you're baking a cake, you're doing everything from scratch. That's what the early days were. Then came cloud computing, right? So it brought convenience and scale. And imagine, let's say you're baking a cake from scratch. Instead, you could just order it from the bakery. That's what cloud computing is. So it lets developer use the servers and services over the internet without having to own them. And this made things a bit easier for bigger and more complex applications. What's next? What came next? DevOps and automation. What is that? What's a cake analogy for this? It's like having a robot in your kitchen, okay? That helps you by automating a lot of tasks. So you still have to do a little bit, but it's helping automate a lot of tasks. What is the outcome? It's this approach that is used for automation to build apps more faster and make them more reliable. So it's going to get a lot more complex. So bear with me. Then came microservices and containers. So flexibility and isolation. So imagine, you're building a Lego structure, but each single part in a building, like the kitchen and the living room or whatever, is like a separate block that you can move around. And this made apps flexible and easier to manage, because every single part here you can see can be developed and operated independently. Then we have platforms and focused on simplicity and focus. So for example, if you're wanting to direct a movie, then all the technical background tasks, like cameras and TV sets and everything can be taken care, and you can just focus on acting and directing. And if we talk about platforms as a service, they take care of a lot of technical background tasks, and developers can focus on building their applications. So a little bit of a background, how we started and where we are. And in the end, I'll obviously end with where we're going, but I'll love to hear everyone's thought as well. So it's DevOps Day. Anyone who doesn't know what DevOps is? Good. So we have Dev and Ops, combining the software development and the IT operations, pretty standard stuff. And when we talk about DevOps, it focuses on collaboration, automation, your CI and your CD, and all these other things. So basically streamlining the development and deployment process. Platform engineering, when we talk about that, it's an evolution on the principles behind DevOps. I'll dive a little bit deeper into it as well. And it takes automation and efficiency goals of DevOps a bit of the step further by building a more standardized and accessible platform for developers. What do we mean by that? When we talk about DevOps versus platform engineering, the first point is the foundation versus the process. So platform engineering is like creating a solid foundation, so like servers, tools, services for developers to use. Developers can focus on making their web application, your game, your mobile app, social media app, whatever you want to do. But you don't have to worry about the servers and the tools and all the other complex services. DevOps is more about the process, so how development and operations teams work together and continuously improve upon the practices. So primary goal of DevOps, if we can say, is to shorten the software development lifecycle, increase deployment frequency, and create a more dependable release process in alignment with your objectives. That can be business objectives or whatever. And the goal of platform engineering is to provide a robust and scalable and efficient, as the name suggests, platform that enables developers to build and deploy applications more easily and quickly. Another key goal when we talk about platform engineering is to create a self-service model where developers can easily access the tools and the resources that they need without waiting for some third party like an operations team or whatever. This is actually an extension to DevOps that is aimed to reduce silos, which is aimed to reduce silos between the development and operations. So it's not like DevOps is being replaced by platform engineering. It's like it's an addition. You can say it's an addition to DevOps. Also, platform engineering emphasizes on building platforms that are scalable and standardized, so you can handle growth for all the users. And DevOps also focuses on scalability, but its approach is more centered on the continuous delivery and the integration pipeline. Some people may see platform engineering as an evolutionary step towards from DevOps, and as the landscape becomes a bit more complex, the role of platform engineering grows, in creating very comprehensive platforms and supporting a wide range of development needs. And when we also talk about DevOps versus platform engineering, the primary focus, let's say in DevOps, automation is key. So your CI/CD, your testing, and all sorts of things. And the types of tools that you're using in DevOps might include CI/CD pipelines, you have the config management tools, you have monitoring solutions, and all these other things. In platform engineering also, while you are utilizing automation, but the main primary focus is creating the platform itself. So it can include various internal development tools, or you can use SaaS products, or your cloud, setting up your cloud infrastructure, service meshes, API gateways, all sorts of things. Lastly, DevOps practices, if we talk about the target audience, are generally adopted by both the development and the operations team. But we talk about platform engineering, it targets primarily targets the developers, and providing them with the platform to streamline their workflows. Cool. We did at Civo, I'm going to share resources in the end. In 2023, we did a little survey, and these were some of the findings. With DevOps, for example, 85% of the organizations said that they either have partially or fully implemented it. And when we talked about platform engineering familiarity, around 40.8% of the respondents in DevOps roles reported a moderate to high level familiarity with platform engineering. I'll share some real world case studies in the end as well. And regarding the impact of platform engineering, they said that around 50% reported that it improved standardization, and 40% saw a faster product delivery. You also saw, when we talk about the future of DevOps, 65% of the respondents strongly agree that the platform engineering is the next evolution when it comes to DevOps. And regarding challenges, the resistance to change and the lack of standardization emerged as the top challenge for organizations for implementing DevOps practices. Can be a bit like you're talking to your team, like, okay, we need to do platform engineering. So there's like now let's say you're trying a new thing. So it can get a bit hard to convince your team members. That's what came up as one of the biggest challenges. And the future emerging trends, which is AI, machine learning, whatever, GitOps, we can talk about it later. But is it hanging? I'm doing next. Okay, never mind. How do we do it? Let's take an introduction to internal development portal. So in the context of platform engineering, it's like you can say a one-stop hub designed for software developers within your individual organization, so tailored towards your organization. You can think of it like a private toolbox where all the tools and the guides and the resources and everything is needed for software development in one single place. And the goal of this portal is to streamline the development process and all the other benefits that we mentioned previously. But the question is, should you build it on your own, or should you use like already pre-made SaaS solution. So when we talk about developing an internal development portal, the advantages include customization because you're building it on your own. So you have, you can customize it as you want. Control, you have full control over the security and compliance and the configuration of the software and the data. You have the integration, because if you have an already existing system in place, it can get bit more easier to integrate it in your existing solutions. Cost effective for large scale, in the long run for many larger organizations with many users. Some of the challenges that come with developing your own internal development portal is obviously the most pretty common sense is if you're building it on your own, then you have to maintain it. You have to work on if anything goes wrong, troubleshooting and all sorts of things. Initial setup cost and time. So you may have to, put in a lot of resources in terms of like monitoring and time and skills or whatever. And scalability challenges might require additional hardware and resources to scale if you're building on your own, and dependence on internal IT. So the team that is building this development portal, you are highly reliable on them for support and development. And in addition to this, if you don't want to build your own internal developer platforms, there's the, if you want to use a SaaS solution, which is like a pre-made some other company who is providing this out of the box for you. Advantages include ease of access and use. You can just sign up, pay a little fee, do whatever, and you get a user-friendly and accessible, platform that you can access from anywhere using an internet connection. Lower initial costs because most of the time it's like a subscription-based model. No maintenance hassle. The SaaS provider they take care of it, and scalability as well. Regarding the challenges, less customization because you're not building it from scratch. So whatever the people are providing you, ongoing costs. So subscription fees can vary over time. They may change the fees, increase the fees over time as you have large number of users. Data security concerns as well, if you're storing sensitive data on external servers and you're actually dependent on the people who are, organization who is providing you these platforms, right? But the question is now, how do we make the decision? What's the process of whether you want to go with an internal developer portal or your own, you have to have let's say, go for the SaaS solution. So start by a comprehensive, taking a comprehensive inventory of your current DevOps practices, tools, and culture. So have the, what the current state is. Think about what is working, what needs improvement, and a critical aspect that was revealed in the survey that Civo did last year was the lack of standardization when you're implementing DevOps practices. So consider how this factor might be influencing your operations. Next one is, what do you hope to achieve with platform engineering? Is it faster delivery times, improving in standardization, increase in efficiency, so on and so forth. So think about what the clear objectives are that will guide you towards your transition process. And in the survey that we did, it also identified, GitOps, AIML, DevSecOps, developer platforms, serverless computing as some of the emerging trends. So evaluate which of the skills and tools are relevant to your organization to, adapt with the industry standards. Platform engineering is, also, we are talking about a lot about tools, but it's also about the culture. And cultivate a culture that emphasizes on learning, collaboration, and transparency. When we talk about the next step, it's creating a detailed roadmap for your transition. So it may include phases such as, the pilot project and how you're going to implement it. And in the end, after, let's say, you've implemented it, how would you continuously refine your platform? The next one being, avoiding the attempt to change everything at once when you're starting out. Instead, implement the changes gradually and learn from every single step. One survey, found that the resistance to change, as I mentioned in the previous slide, was a significant challenge when implementing DevOps practices. So rather than doing it at once, implementing gradually and learning from every single step. And when you're implementing this new framework, also design clear metrics for success. So for example, how frequently you are deploying, lead time for changes, failure rate, mean time to recovery, so on and so forth. And I know I mentioned this already, but it's a continual process. So learn from your experiences and refine and improve your practices and tools and culture. Cool. That was like if you want to take a picture, but it's being recorded as well. If we talk about what is next for platform engineering, it's like I might have to put like, I think platform engineering should be here or sysadmin should be there, but you can be the judge of that if this is right or wrong. I think the next step would be abstraction. Like cloud providers provide abstraction over VMs. Kubernetes provide abstraction over containers, and now platforms are doing the same thing over services and applications. So we would see, I think, further drive for automation, making it basically more accessible for engineering teams. The challenges, the one that I didn't mention is also how to make it secure, how to make your platform secure. And for larger organizations, they're like SOC compliances and all these other things. And some people may use, like you're using a cloud provider and you're also having your own solution. So in the hybrid environments, how do you take security into consideration? So I think more automation, more building blocks are essential. And people are realizing that, throughout the organization, the same problem is being solved like 5 or 6 times, just like by slightly different teams who are, actually, developing it. And as a business, what in an ideal situation, you only want to develop you only want to develop it once and have a capability for the rest of the department to use it. So for example, if you want, let's say, a Civo Kubernetes cluster, you just have a Kubernetes cluster and people are using it. But let's say you want Redis and you have this little catalog that you can just drag and drop and use Redis in production. And now you're getting the replication and backups and everything out of the box. So you don't need to do any like tooling or configuration. So that's in an ideal world, you just build it and then people across your departments can use it. Now, so that's what developers need. They're not thinking I need this version. I need a Kubernetes cluster here and there. I need Vault deployed here and there. They're just like I need Node.js deployed to production and I needed it yesterday. So I think that's basically what is next. I think more automation, and we're also seeing the integration of AI and machine learning into platforms. So the cake example, just make the robot more smart, like smart assistant in your kitchen that can learn from your recipes and suggest new ones or whatever. But and continuously also learns and adapts, improves over time. So I think automation and maybe something with the AI and machine learning in the future. Some resources that you can try out. This is a nice open source community you can join. It's called platformers.community. So it's specifically specializing with platform engineering. So you can check that out. Dinesh, our CTO, and Will from North Flank, they did a webinar. So you can find it on Civo webinars as well. I did a video on platform engineering and DevOps trends on the Civo YouTube channel. You can check that out. There was also an interview between Zoe and Carolina on the Level Up Engineering podcast. So they basically outlined the challenges and the support surrounding platform engineering at HubSpot and how they have adopted platform engineering to create a self-service platform that empowers their developers to focus more on writing code and less on managing the underlying infrastructure for the developers. So you can check out this podcast as well. There was also an interview by, I believe I'm pronouncing it correctly, Jean-Michel, former CTO of Shopify. It's the Engineering Enablement podcast. So he advocates for allocating 50% of the R&D resources to platform work, arguing that it's good for long-term business impact. Just those are some of the nice resources, but I'm happy to learn from your experiences as well. So I'll be walking around now that I'm done with my talk. So you can find me at the Civo booth or just look for this T-shirt. But I'm also on Twitter or X that you can reach out to me. lastly, I'd just like to end it with that the transition may seem daunting, but as I gave some examples and the case studies, the implementation can yield a lot of benefits. The key is thorough preparation, understanding the necessary tools, technologies, and skills, and planning a detailed step-by-step transition strategy. And try out Civo as well. If you need a platform, so we have a lot of services, and if you sign up, you get $250 worth of free credit, and we also have a community Slack channel. We have I think 30,000 people. So if you have any questions, let me know. But yeah, I think that was it. Am I done? At the time? Okay. Am I over time? Okay.